Jai Hind to everyone. My name is Vikas. I'm an assistant professor at Department of Computer Science and Engineering Department. Today I'm going to discuss the transmission control protocol and user datagram protocol at the transport layer. And I will be discussing the numericals or the questions that are generally being asked in the university papers regarding these two protocols are there. So, further going on ahead. So this is the or means picture representations where the what kind of protocols and at what layers are being used. They are being there. First one is application layer. We have the SMTP, FTP, TFT, or SNMP, and so on are there. And the second one is at transport layer, we generally use three protocols are there, that is UDP, TCP, and TCP is there. At network layer, we use the IGMP, ICMP, IP, ARP, and reverse ARP. I will be discussing these two here in this the TCP and UDP here, and I will be discussing the what kind of headers are there, what are the various subsections of those headers are there, and on the basis of that, what kind of questions are generally being asked on these tools are there. So, as I already know that at transport layer, we have to transfer the data between the two entity, or you can say there are two nodes, that is process to process communications that happens. Why it is being process to process? Because at transport layer, we use the IP address as well as the port numbers are there. With the help of this, we can send or receive the data between the two nodes are there, or you can say if we have to fetch the informations from the server, then the client and the servers, how they interact with each others, what kind of services that is being needed by the your client, and on the basis of that services, that information is directly sent to the that part of the sections, or you can support there on the server sides are there. Okay. So, let us further go ahead. TCP is basically a connection oriented protocols. It creates an virtual connection between the two TCPs, or you can say two nodes to send and receive the data is there. So, in additionally, they basically uses the flow and error control mechanism at the transport layers are there, in which they basically have to create connections between these two nodes. After creating connections, then they can send or receive data are there. For that, this in TCP, we generally, if the security is major concern is there, at that time we use the TCP protocols in order to send or receive the data are there. In the TCP, there are three way of handshaking has to be done. First, a request has to be sent from the sender to the receiver, and receiver will send an acknowledgement. Yes, the receiver is ready to accept the data. After once the sender receives that acknowledgement, it sends a message to the receiver. Yes, now they can start sending the data as are there. So, as I already told you that in TCP, there are certain well-known ports are there. On the basis of those ports, we can send send a request directly to that portion of the at the server sides are there. So, this is the header of the your TCP is there. It is basically a 32-bit is there, and this is the header part where all these things comes into considerations, and this is the data part is there. In this, we have the source port address and the destination port address must be there. Both are the 16 bits are there. Then we have the sequence numbers of 32-bit and acknowledgement number of the 32 bits are there. Then we have now header length which is being 4-bit, this header length size is minimum 20 bytes and maximum is 60 bytes are there. So, it means whatever the value is there, we can send the, or you can say we can define the header length either 20 byte or the 60 bytes are there. Then the next 6 bits are being reserved here, which is being used for the future use. After that, we have the 6 flags are there, which is generally being used, or you can say they are being defined in order to what kind of informations that we are sending or receiving the data is there. On the basis of that, the flags has to be up. Let's suppose if we have to send the data urgently, then we use this, we have to up this flag are there. If the data is being received, now we have to send an acknowledgement, then we use it, this flag to be up there. Then we have a push, or if we have to reset the connections, then we use this this one RST, that is reset is being used. If we have to synchronize the data between these two nodes or sender or receiver, then we use this synchronizations flag has to be up. Then if data is being finished, means last data is there, then we use the finish is there. Then we have a 16-bit window size is there. Then we have the 16 bits of checksums and the 16 bits of other bits are there. Then we have an optional paddings are there, which is being there in this, just like your IP version 4 headers are there. So, this is the headers are there. In this generally in university exams, we generally get the hexadecimal values are to be given to you. Now, you have to identify, or you can say you have to divide that hexadecimals values and put it in these sections are there. So, in order to do that, you have to remember this header formats are there, which is very necessary. Otherwise, you will not able to do those numericals are there, which are very easy, and anybody can able to do it if they know this header formats are there. So, I will be discussing in the discuss this numerical on this also. So, as I told, this is the flags that has to be up according to the requirements are there. These are the well known ports are there, which is being used for the sending or receiving the data are there, and on the basis of that, when the or you can say when the client is sending a request, they can send they send the request along with this these ports numbers are there. So, according to these port numbers, they once the server receive those requests, it checks the port number, and on the basis of the port number, it sends the request to the that particular location in the servers are there. Another is next is user datagram protocol is there. As I told, as its name suggests, it is connectionless or unreliable transport protocols are there. So, in this UDP, we generally don't need to create connections between the sender or receivers are there. Sender just directly send the data with respect to the port numbers, and the receiver will receive it, and they synchronize the data at their own end. So, in this UDP, we have a process to process communication instead of host to host communications are there. So, in the TCP, there will be a process to process communication instead of host and host communication. Host and host communication generally happens at the network layer. So, as we are discussing the transport layer protocol, so we say it is a process to process communication. Why? Because it consists of the these process to process will consist of your IP address plus port number. So, on the basis of that, that is why it is called process to process communications are there. So, generally they basically comes to as we can socket programming is being done at the transport layer are there, which is another another topics, vast topics is there. So, I will not going to discuss it. So, UDP is connection less and unreliable transport protocols are there, where the sender send the data and it does not bother about whether the data is being has to be received by the receivers or not. Once they receive the communications, that data is not they send the data and leave it there. So, it is a responsibility of the receiver, the receiver, which they will collect the data and synchronize the data at their own ends. So, these are the well known ports numbers with respect to your UDP are there, in which we have an echo, discord, as daytime, caught, charge and return string characters are there, and we have an names server and so on, etc. are there. So, if let us suppose in the UDP clients wants to know the date and time of the server is there. So, they send a request with the this port number is there, day time, and this in the sender in their header, UDP header, the sender port number where that has to be sent, that will be defined, and it will send to the server. Server will respond back are there. Okay. On this, so there another protocols are there, port numbers are there, which is being used for the sending the data over network in the transport layer by the UDPs are there. So, this is the header diagrams of the UDP is there. In this, we have a pseudo code which we have a source IP address and destination IP address are there, and we have an 8-bit all zeros are there. Then we have an 8-bit protocols are there. Then we have a 16-bit UDP total length header is there. Then this is header is there, where we have a source address number, port number address is there. Then we have a destination port address is there, and this is the UDP total length of the data that has to be sent, and this is the checksum of the 16 bits are there. So, generally the questions that are being asked in the university exam with respect to UDP is based on the these four headers are there, or you can say 4 sections are there. On the basis that you have to define the what kind of what type of numbers are being present there in this headers are there. So, we have to place these numbers according to the this headers are there. So, this is the again this is the header, and the data is there, which is the header is of 8 bytes are there, and this is your source, port number, destinations, total length, and the checksums are there. So, let us take an examples or you can say questions that are generally being asked in the university papers are there. So, first take an examples of the TCP. In the TCP, let us suppose we have received hexadecimal values are there. In this hexadecimal value, we have these numbers are being sent there of the 8 bits are there. Now, we have to identify the what type of source port number, what is the source port number there, destination port number, sequence, what is the sequence numbers are there, acknowledgement number, length of the header, type of the segments, and the window size are there. So, in order to determine, as we already know, this is 32-bit value header length is there, in which we have a 16-bit port number, 16-bit destination number, then we have a 32-bit sequence number, 32-bit acknowledgement number, then we have a 4 bits of header length is there, then we have again 6 bits are being reserved for there, then we have 6 bits are being left for the for the further 6 bits are there for the flags are there, means in which we have to identify what type of segments, what it is being intended to do is there. Then we have a window size is there, and so on. So, we have to put these values according to this here. So, if we say what is the source port number is there, so as this is the 8 bits are there, so it means in the source port number we have the value is 0, 5, 3, 2 is here, and for the destination port number remaining 4 bits are there, so it will be 0, 0, 1, 7 is there, not there. So, these are the values that you have to put here in this, and as this is sequence number is 32 bit, so we will be using these it will come at 1, 2, 3, 4, 6, 7 and 8 will be placed there, and we have an acknowledgement number is there, then it is again 3, 6, 8. Okay, so the 8 bits are there. Now we have comes to the next level, where we have to identify the what is the header length is there, as this is the 5 is the header 4-bit value is there. For each characters, for each numbers we have the 4 bits are being used for the defining these numbers are there. So, 5 is the your header length are there, then we have to go for the segments are there, then as segments we have to identify this 0, 0, 2 has to be converted into a binary numbers in order to identify what kind of flags is there. Then we have an 0, 7, FF are there in order to determine are there. So, on the basis of that we have to things is as we place this value, now we have to convert these into a decimal value, so that as a human we can able to read what kind of numbers are there in order to determine according to the headers are there. So, let us take in this is the examples that I already discussed is there. So, source port number is 2 bytes, that is your 16 bits are there. So, which is 0532 as I already told you. So, this is 2 byte long field is identify the port number source. The source port number of the first 4 hexadecimal digit is this, we have to convert into the binary number. So, when we convert sorry, not binary, that is decimal, when we convert into decimal, this will come out as a 133 is there. Okay, so we will place here 1, 3, 3, 0 here in this case. Now, next we have to define the destination port address, and the destination port address is of the again 2 bytes, that is your 16 bits are there. So, we have 0017 is there, now we have to convert into decimal. So, it will come out as a 23 is there. So, we place here 23 here. Now, the sequence number is 32 bits, which is of the 4 bytes are there. So, it will be, we have to write here 7 times 0 and the 1 is there. And in the acknowledgement we have the all numbers of zeros. So, we can write one single zeros can be put here. If we have to write 32 bits, then we have to write all the 8 times zeros are there. Okay. Now, next we have to define as per the questions, we have to identify the header lengths are there. So, header length is your 4 bits are there, and values that is come into is 5 is there. So, this will be come out as an 4 into 5 into 4, that is 20 bytes are there. As I told you, the minimum length is 20 bytes and maximum length is 60 bytes are there. So, header length will be here 20 bytes are there. So, next 6 bits are being reserved. So, we are not going to that. Now, we have to identify the sequence number, and once that this 5002 has to converted into an binary numbers are there. In order to convert it, then this will be come here, and as the 6 bits that we have taken into consideration for the flags are there. So, 1, 2, 3, 4, 5, 6 are there. Then here in this second flag is being up. So it means the sync 1 is up here. So value here is 1, rest are the 0 here in this case. So we say what kind of segment this is there? This is the synchronized segments, synchronized flag is being up, and that has to be defined there when we say it is a 1 here in this case. Now, next is we have to we have been asked in the questions, window size is there. Window size is 16 bits are there. So we have the 07FF is there. So when we convert this into an decimal value, so it will come out as an 2047 are there. Okay. So checksum is another thing is there, and urgent pointers, and we generally these 7 things that is being asked in the university papers are there. So this is with respect to your TCP is there. Next example is with respect to UDP. Again, we receive the hexadecimal values. Now we have to identify the source port number, destination port number, length of the user datagram, length of the data is there. As well, you know that there are the 16 bits are there. So we have to define the 16 bits into there. As we identify in this manner. Okay. So let's convert it. So source port number will be 0632, then we have a 00D, then 001C is there, then E217 are there. So we have to like this. So it will be first we will define the source port number. Then destination port number will be this here, 000D is there. Then the next value that we have to identify the length of the user datagram, 001C, 001C here in this case. Then E217 is there, then which will be length of the data is there. So again, we have to convert this into decimals values are there. So source port is 2 byte long, field used to identify the port number of the source. The source port number is the first 4 hexadecimal is there, that is 0632 is there. If we convert this hexadecimal to decimal, we will get the 15862 is there. So this will be the value that we have to put in the source port numbers are there. Now we have to identify the destination port number. As it is 2 byte long, field is there. So we which is used to identify the port of the destinations packets. So the in this given the hexadecimal values, next value that is 00D is there. So if we convert into an decimal, so we will come out as an 13 here in this case. Next is we have to identify the length of the header is there. As it is 16 bits are there, so it will be 001C is there. So if we convert this hexadecimal to decimal, we get the 16. We get 16 defines the length of the whole pack is 28 are there. So the length of the header will be 28 minus 8, that is your 20 bytes, which will be the as it is 8 byte is fixed. So length of the data in the whole packets will be which is equal to 28 minus 8, that is 20 bytes are there. Okay. There is another example of the UDP in which we have to define the 04, 2100, 2B, 002A, E2 and 17s are there. As we know already that is 16 bits. So it will be this will comes as the source port is there. This will comes as a destination port as there. This will come as the length of the datagram is there, and this will come as the length of the data is there. So we have to convert these hexadecimals values to the decimal values are there. So if we convert it, so for this 042, if we converted this hexadecimal to decimal, we will get the this number is there. and if we have the destination, next we have to identify the destination port number. As this is the hexadecimal value is being given, now it is being converted into the decimal, then this is the your 11 is will be come out as the decimal value. Third one is your identify the UDP packet length is there, packet is there. This is 002A, which come out as a 42 here in this case. So as the length is big, data length is fixed there. So length of the header will be come out at 28 minus 8 again. 20 bytes will be come into the as a length of the data is there. Okay, so these are the one of the few examples are being there. Another example is there. Sorry, this is the fourth one example. Again, we have a dump for the hexadecimal value where we have a UDP is being there 0361, which will be as a port number here in this case. Okay, so and this will be your destinations. This will be your datagram, and these will be your length of the data is there. So we have to convert these again. We have to place this according to the what kind of length is there. As this is 16 bits, so 2 bytes are there, has to be there, which will be used to define how many hexadecimal value will come into the source port number, how many value will come into the destination port number, and so on. So if we convert it into decimal, we will get this. We will if we converted this into hexadecimal into decimal, we will get this. This is the value that we have received. Now we have to convert it into a hexadecimal value that we receive into decimals. Then this will be the value is there. This will define the length of the whole UDP is there. Then the length of data is, as we already know, 28 minus 8. That is fixed here in this case 20 bytes are there. So thank you for this. Now the questions generally that has been asked or come into mind, why we have to convert these into decimal values are there. Can the student place these numbers directly there? I suggest that student must convert these hexadecimal values into decimal values. Why? Because computer can able to understand these hexadecimal values are there, but as a human being we are not able to read those. So we have to convert this into decimals values are there. Okay, so in this way we if we convert this into decimals, then it will be easy for the human to able to read those values are there. So but one thing that has to be clear, in the UDP, we have to convert into hexadecimal into decimal values are there. But in the case of TCP, where we have the flags, in that flags, we have to convert the value into binary is there. Apart from that, rest has to be converted, into your decimal values are there. So we say in the TCP we converted this converted all these are the decimal values are there, but here in these 6 bits, that is flags, has to be converted into a binary. So we converted here into binary here in this case. So you have to take into considerations. So I hopeful this presentations or video lectures will be helpful for the students in order to solve these such kind of problems are there. Thank you.